Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. I'm Trevor Eddles. I'm CEO of iTechEd Limited. We're a mainframe consultancy analysis and technical authoring organization, and we're the people responsible for the content on the virtual IMS website, and we produce the newsletters. So if you haven't been on the website yet, it's at itech-ed.com/virtual IMS. Let's run through the agenda for today. So most of the meeting's going to be taken up with a presentation, and today our guest presenter is Dusty Rivers. He's Senior Director, US Systems Z at Mainline Information Systems. And his talk is entitled 5 Real-World Production Use Cases of Mainframe Applications. That's IMS, CICS, etc., acting as real-time clients to distributed systems, cloud, third-party, in industries such as banking, finance, and manufacturing. And a copy of the slides from that presentation should be on our website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentations from our website, and you can listen again to them. There's a link on the resources page. So following Dusty's presentation and any questions you have for him, and today it will be handy if you can just type the questions into the chat, and I'll pick them up, and we'll do that at the very end of Dusty's presentation. So after that, we've got IMS news, the latest IMS related articles. Then I'll give you the dates and times for the next virtual meetings. And that's the plan for this meeting. And I'm anticipating that it will last for perhaps just under an hour. So let me just admit some more people. Or actually, no, what I'm going to do is I'm going to hand over the session to Dusty. Now, Dusty tells me that he's a well-known speaker at global events dealing with mainframes, IMS integration and architecture. He's an IBM Lifetime Champion for Z and a member of the Program Council IMGT at Share. He's got over 45 years of experience in IMS and mainframe systems. So let me stop sharing my screen. Let me admit anyone who hasn't been admitted, and let me hand over to you, Dusty, and let me thank you very much for being with us today.
Well, thank you. Can you hear me okay?
Yes, thank you.
So can you see my screen?
Yes, it's already.
So, yes, already. So thanks for coming today. What I'm going to do is actually, this is kind of a superset of a presentation that I did at the recent Share conference. And one of the things that I wanted to talk about is there's a lot of interest in the news. There's a lot of interest talking about mainframe modernization. And I thought what I would do is obviously the user stories that I'm going to talk about are from five clients who actually took the journey to modernize their systems. But before I talk about what they did, I'm going to go through a couple of slides really quickly. When I talk about mainframe modernization, that has kind of a connotation, and I want to go ahead and get a few things out of the way first. First thing, I consider the mainframe a modern system. You know, when people tell me, the mainframe is old, I can counter all that. The mainframe to me is the most modern system today, but we need to change the way we interface with the mainframe. Obviously, some people are like me are familiar with ISPF. Some people use visual code. Some people use command line. We also need to change the way we think of the mainframe. There's a lot of discussion in this area. So I'm just going to kind of phrase everything we're going to talk about today in that mindset. So when I talk about mainframe modernization, the first thing everyone assumes is I'm going to say, we're going to move off the mainframe. But I will put a big no on that. I'm not going to talk about moving off the mainframe. My definition of mainframe modernization is not moving off the mainframe. And my favorite line for all of us on the call here, this is my favorite line from a customer a couple of years ago. They told me, hey, we're moving off the mainframe. And my question to them was, how is that going for you? And their line was, we are 10 years into our 2-year plan to move off the mainframe. So, it's not for the faint of heart. It's not what they would expect. So when I talk about mainframe modernization, I talk about mainframe modernization, and I've done presentations before at Share and on this IMS forum on the virtual users group about modernizing the look and feel. Maybe, there's still needs to GUI some screens. Maybe there's some third-party systems you need to turn into APIs. You need to maybe make the data more accessible, API enable the data, make the data on the mainframe more accessible, make the business logic accessible to new applications through APIs, through modernizing how they're accessed, how they're combined in APIs. Use modern programming languages. In this vein, if you've seen a lot of the presentations, new languages that are more in the distributed workspace are now on the mainframe. There's Go, there's Node.js, there's Python, there's Java, making the mainframe with more modern programming languages. Also, more complex business processes quickly exposed. The idea to combine maybe microservices or some APIs into one API. Also, the need to get in grip with new technology. This is where the mainframe is communicating with cloud systems. The mainframe is with the using OpenShift on Z or ZCX, or using the mainframe in new ways. Also, I incorporate into that bullet things like DevOps, including Ansible, including Urban Code, including things like that in the mainframe. And the need to have the mainframe call out to off-platform applications. The need to migrate applications. Yeah, there may be needs that there are applications that are right-sized that may work on other applications off the mainframe in the cloud. And what we're going to talk about today, I kind of went through those really quickly just to say, I've talked about some of those other topics in other webinars. I'm going to talk about today, we need the mainframe to be able to participate as a first-class client. Also, as a bonus, at the end, I'm adding 3 new bullet points to my mainframe modernization. So the first thing I want to throw out there is in past discussions I've had, when we're talking about the mainframe, we talk a lot about, and hold on just a second, we talk a lot about issues. And the issues aren't really issues, they're more things you have to be concerned about from the distributed applications in talking to mainframe applications. Things like there are constructs on the mainframe in COBOL. There are programming languages like COBOL and PL1 and assembler. Some of those don't lend themselves to working well. So there's a whole presentation, is probably out on Trevor's log of mainframe integration, the good, the bad, the ugly, lessons learned, problems. So there are whole sessions that go through these. So you may have seen this chart before, but these are a lot of the things that you have to look at when you're looking at exposing mainframe applications. And there's a whole list of these, but we're kind of flip the script here to the other side of that. Okay, from the mainframe, and depending on who you talk to, they're either called callable services or outbound services. By that, what I'm talking about is you want to access external services via COBOL or PL1. Now, by access, I mean you want to do a real-time call. You're not offloading data. You're not copying data, moving it somewhere to analyze it. You're doing real-time calls. And in all the use cases I'm going to show you, they're doing real-time calls out to other systems. Also, these are COBOL or PL1 users that are talking to these distributed systems. And so in some cases, they don't want to learn a new language. They don't want to learn XML. They don't want to learn REST. They don't want to learn Swagger. Also, one of the things you want to do is you want that COBOL programmer or that PL1 programmer to be comfortable just calling the API or the distributed system as if it's another subsystem or a subroutine on the mainframe. But in there, and I'm going to talk about this a little later, is all the processing of all the TCP/IP services for the target service, the things like marshaling of data. By that, I mean, obviously, there are data types in Java, different from COBOL. They're ASCII to EBCDIC. All that is handled, so you don't have to worry about that. So what I want to talk about here is, let's just think about what we have when we talk about mainframe systems. We have COBOL programs, we have PL1 programs, we have assembler subroutines, we have IMS, MP regions, BMP regions, or other regions. We have CICS programs, we have batch programs, and we have IDMS. The reason I put IDMS up here is because one of the customers actually has that. And the reason I've got all the question marks after it is because when you're dealing with IDMS systems, there's a set of SVCs that are different in IDMS. They have their IDMS has their own set of SVCs that are used to do certain functions. So what I'm going to do is, you notice I just put a box over all of that. So by that, all of the interfaces I'm going to be talking about are common and shared among all those environments. So I'm just going to say, when I'm talking about the customers, I will differentiate whether it's IMS, whether it's batch, whether it's online or whatever. But let's just take it in a, I don't want to say black box. It's supposed to have been a blue box, but it came up as gray for some reason when I put it on here. Is so from the mainframe, IMS, from a transaction, calling out real time to Salesforce, to SAP, to any cloud application. And I've got the big red question mark there because it's really anything that's not on the mainframe talking real time out. So one of the things as I start talking about what these customers experienced is, on the left, you obviously have all the stuff that I was hiding, COBOL, PL1, IMS, CICS, batch, and IDMS. But on the right, you have different message formats, things like Open API version 2, version 3, or open standards like Open Banking or Open INS or Fed Now. You have Swagger, YAML, JSON, WSDL, and other message. There's tons of formats out there. So the idea is the little red line there is basically saying there's things you have to think about. And you'd like to hide as much of that as possible so you don't have to worry about it. So the mainframe, from your IMS transaction, you're calling out to an API somewhere, and you're going to get the answer back you're expecting it. So if I kind of think about that kind of in the middle there, the steps are common for everything on the left. You have to figure out where the service is you want to call. You have to know where it is. You have to know what format it is. Is it JSON? Is it Open API? What version is it? Is it YAML? You also then have to say, well, I want to generate the necessary COBOL or PL1 stub codes necessary for the mainframe IMS application to call that distributed service. You also want to incorporate that code that you generate into your to a stub code that can be included in the program. And then you have some sort of API server that's going to handle all that work that I talked about, the calling out, passing control, doing the data marshaling, doing the TCP IP, all of that stuff. Then you obviously want to deploy and test it. So let's use an example, and this is actually a real example of one of the use cases. Okay, locate the service to call. There is a service out there in public domain. It's under Google APIs. It's called geocode. This gives you the longitude, latitude, all the information about every address anywhere. And you'll notice in red is kind of the information, but in black, there's a place ID and there's an API key, because obviously you have to have a key to run it. But this kind of tells you, okay, this is where the service is. But then you need to figure out, okay, what does that look like? In this case, this is the JSON of what it looks like. I mean, you basically supply an address, and it gives you all this stuff that you probably never knew existed about your address. In this case, that you'll see at the bottom, the place ID, that CH long word there, is actually the place ID that's used in this API to talk about this address in Brooklyn. Your API key is plugged in. So if you think about that, okay, my COBOL program, I want to call out to get the longitude and the latitude. So what I want to do is I want to basically say, okay, from my COBOL program, I have an input field called Google address. It's a PIC-X30. And then my results is actually an occurs 10 times, not occurs depending on, sorry. And here's the information. And the two fields that I'm interested in are latitude and longitude. The other things I can use. So basically what we've done is we've discovered where the service is. We've imported the format. We're going to generate the code. And in generating the code, we have to have an input and an output copybook that we're going to deploy and test that. So that's kind of a very short example of kind of the pieces that I'm talking about. So in the topology of what I'm talking about, and I'll share with these later as we get into customers. And again, I'm using my my gray box and my blue box. On ZOS or ZOS, I have a program that's going to call into some stub code that's generated. That's going to call into an API server, and that API is going to call out to whatever. In this case, I've got several cloud vendors. It could be anywhere. In this case, the API server is located running on ZOS. That's what you want to do. That's fine. And I'll show you these in the customer examples. Maybe though, you want that API server running on a Windows platform or a Linux platform, or even running on an IFL, running on Linux on Z. Or maybe you want that running in an OpenShift or a Docker container out there in whatever platform, or you want to use CICS and run that API server running on OpenShift on Z, or one customer is even running the API server in the cloud. But if you noticed in all of these examples that I went through, the program on ZOS, the IMS transaction, doesn't care and doesn't know, nor does it need to know where the server is. So you can actually independently invoke or set this up where you're not basically putting requirements on the application. So Trevor and I were talking about grandchildren before we got on the phone. And when I was doing this presentation, my grandson, who is a big Minions fan, said, "Pops, you don't have any cartoons in your presentation." So he made me put these Minions in. So you'll see these for the rest of the presentation. I use these at Share. So I take no credit. I will give my grandson credit for this. So the first one, we're going to get into case studies. And I'm going to make these as generic as possible. The first case study is a large Swiss bank. Now, this Swiss bank had the requirement to implement customer verification, the idea of verifying that a new customer opening an account was not a known criminal or a terrorist or a money launderer. And there's a system out there called WorldCheck, which I kind of equate that to like an Interpol check to make sure that this customer is okay to do business with. Now, WorldCheck has a uniform set of APIs that can be initiated. In their case, they're running an IMS PL1 program in their mainframe core banking system. So what they wanted to be able to do is when a customer opened an account, real time, whether it was from a web app, from a branch, from any place opening a new account, to go through this system. So what they did is they created this calling mechanism from an IMS PL1 transaction. They called out to WorldCheck and got the verification. Now, a couple of caveats here. One of the things they had to identify, obviously, with all APIs in this case, they had to set up a set of IMS message processing regions for this transaction, because for the duration of this call, that MP region is blocked. It makes the call and it's going to wait for a response to come back. So you have to, they made provisions for doing things like, okay, I have a set of multiple regions. I set up some reasonable timeouts. I set up some reasonable timing, and I kind of segregated out those regions. So the idea is they set this up in their business to do this. In their case, as you see, they're running the API server on the mainframe because they wanted to basically have it under control of the mainframe group. So as I mentioned, their challenge was to set this up. Their solution was develop the APIs, and what they wanted to do was do this without making massive changes to their program. They found out there was a couple of programs they needed to make this change in. They created the API call, they created the callable artifacts, and they did this. But they also were able to figure out, okay, once I did this for one application, these routines were reusable for, as I mentioned, their web apps, their 3270 apps, and program-to-program calls. In one case, we actually went into a branch where they did this and showed how it actually worked with the people in the bank not really realizing this is what was happened. They were also able to do this very rapidly, and they were able to do this under the regulations. This was actually a change that was mandated not by the bank. It was mandated by the Swiss Banking Consortium to do this. The second case was a national testing service, and what they realized is there was some information that they were using, and in their ways of doing business, when you register for a certification test like a language test or a graduate test, there were needs to have that verified. When you paid for the test, you put in your credit card information. Well, what they found out is in some of their cases they were storing the credit card information, which would have failed a PCI audit. So what they did is they said, we can't do that anymore. So they wanted to do real-time credit card authentication from their web testing applications, from their testing center. And also they needed to provide information from, back to what I showed you earlier, they needed to direct people to the test to say, if they wanted to use Google Maps, they had to figure out, okay, where was the testing location? It had a geocode associated with the physical address, how to get that. So in their case, what they did is they are using, in this case, they're using CICS, COBOL. They're also using IMS DC, and they're calling out to a credit card service real time, and they're calling out to Google Geocode. This was done in a couple of months. They were able to do this, pass the PCI audit, but in this case, they didn't have to make major changes to implement this change. Also, they were able to do this rapidly. And one of the things I'll say is, to do this, we're not talking about years to do this. We're talking about weeks and months. So, the old agile methodology, you can use this because this can be done very quickly to implement these changes. The third case is the French bank. In this case, the French Banking Consortium had dictated that in the French banking world, they were going to have to do what's called real-time payments. The idea there was they were going to have to do money transfers immediately. So, and they were complying with what was called KYC, or Know Your Customer, and also real-time payments. The idea of, if I send Trevor money and I use an application called Venmo or Zelle, that money doesn't usually get transferred instantaneously. My application sends money to an intermediary, which holds the money, which sends it to Trevor's bank, which notifies him, and eventually, maybe within 24 hours, that happens. With real-time payments, when I say send that money, the funds appear in Trevor's account almost instantaneously. So you have to consider what I just said, the security, the cyber security that has to be there to verify accounts on both sides, verify balances. So in this case, there's a system called Clear to Pay that they used, and they implemented this, and they said, wait a minute, there's some other security we need to do. So in their IMS system, in this case, it was Peel 1, they implemented this this technology, got it to work, and then someone mentioned, wait a minute, there's another level of security. So in their case, they actually used a product called Axway, which is like an API gateway that they had already used in other applications to enforce some of their OAuth security. And so they basically plugged it in. But if you notice to the left, that IMS program never knew those changes were made. So the idea there is this was done, again, driven from external services. It was driven by the French Banking Consortium. It was done very rapidly. And, as a kind of a testament to how it can be done, I've kind of highlighted at the bottom, from proof of concept to production, this took less than 2 months. So the idea is we're not talking about, again, months and years. The third one is one of my favorite ones, is the airline. The airline implemented, as a result of a merger, they had some regulatory requirements. They needed to rapidly unify the aircraft maintenance systems and parts systems into a seamless interface. And they presented this at a couple of share conferences, and they talked about how they did that. Just as a note, they're running over 1 billion APIs a year through this API infrastructure now. But what they discovered is another part of their business went out and purchased a printer management system that manages all the printers. And if you think about, if you go to the airport, and all of us have been at the airport, when you're at gate 1, they've got multiple printers at that gate. And if one of the printers goes out or they need to find another printer, they need to figure out, okay, if I'm at gate 1, is gate 2 available? Is gate 3 available for a printer? I need to print something. What is the type of the printer? Is it available? Is it ready? Does it have all of those things that you look at in a printer system? Well, the printer system that they bought was actually a Windows-based system. And so what they figured out is, okay, I've got my big API infrastructure. How do I do that? So the first thing was in their environment is they had already figured out, okay, they're running IMS, they're running COBOL apps on ZOS. In their case, they were running multiple Linux servers, running the API server, and it was talking to and from their IMS system. But what they immediately realized is, oh, I need to also include calls from that IMS application out to the printer management system. And then they came up with another paradigm, and I'm gonna throw a confusing chart up. So from the left are all the mobile devices. Depending on where they are, they go through the network, they go through an application server, they go through a traffic manager, and in this case, they're both F5 switches. They go through an API server, they go through the transaction server, through TCP/IP, through IMS Connect, into IMS, and they run the transaction. And all the red lines kind of show, hey, that answer goes back to the users. But what they figured out is, wait a minute, I got to find the printer. So from the mainframe, they had the issue where, okay, from their terminal applications, which some of their applications are still terminal based, is they had to make the call to get the printer, and everything worked fine. But since they went to the printer system, what they immediately found out was maybe the device is all the way out to the left. So if you go with me on the red lines, is from the left, the application makes a call, it follows the red lines all the way into IMS, and then that transaction says, wait a minute, I need a printer. So from that transaction, it calls back to the printer management system, also comes back to the transaction, goes all the way back out. So you can imagine, we did a performance study looking at this. All the points here, everything has to be tuned. The idea is everything worked fine because everything was API based, and everything was basically done very quickly. Again, they run this, multiple millions of times a month. There's a billion APIs going in and out of this system. Everything is running like it should. Also, to do this, and this is another discussion, is if you look at all the platforms, all of the changes to put a release in, if you think about, they immediately figured out, how do I manage this? So, and this is another topic, but I just wanted to throw it out here, is they built a complete DevOps CI/CD pipeline from the UI all the way to the mainframe to support this, putting new releases out. So, if someone, as part of my modernization, when people say, yeah, the mainframe can't participate in a DevOps pipeline, I can say, yeah, it can, and it does on a daily basis. My fifth one that I'll talk about is just a US-based food supplier. And if you think about a food supplier, they're supplying fresh food, fresh produce, frozen food, beer, because they're a large beer distributor. They supply it to hundreds or thousands of users. And one of the things they did is they had multiple business units, and they also had SAP. And as a result of combining those business units, what they needed was, from all those systems on the mainframe, when an order was produced, they wanted those orders to be reflected in SAP. Well, they thought about, well, we'll just pick up all the applications and move them to SAP, which was going to be too big of a daunting task to do that. So what they decided to do is they said, why don't we write an API? We know that there's five systems of record that put out orders. So what we're going to do is we're going to create an API from those systems. When an order is created or a logistical order is created, we're immediately going to reflect those in SAP. Well, then one of the things they realized is they wanted guaranteed delivery. So they have a program today that's running with MQ series. And basically what they did is they have the API calling a program on Linux that basically accepts the message, puts it on a queue, guarantees the delivery, and then pushes it to SAP. This is across 6 business units. This was a direct call to SAP. We started out with the program was calling SAP directly. It worked fine. Then they wanted guaranteed delivery, so they actually put the MQ step in the middle for guaranteed delivery. Again, this was done in a couple of months, and they're actually adding more and more to this. So, I think you see it in some of these cases, and I went through all of them kind of rapidly in consideration of time. We could talk more about any of these use cases, but the idea is this is running today. So I didn't pick 5 use cases that were going to go production. All 5 of these have been running production for a while. So these are battle tested. These are battle hardened. They're secure. They're performant. And one of the things I wanted to mention, and so mainframe modernization covers a lot of tasks. So I was going to cover 3 at the end. And so in modernization, we talk about a lot of stuff. So when I was talking to someone, these 3 words are coming up more and more: sustainability, security, and AI. And so sustainability, the new systems are smaller. They use less power. They take up less space. You can move in some of these sites where we were just talking about. They have a lot of servers out there that are like a Linux server. They're collapsing those down on like one big Linux one. Security, they're looking at obviously the words cyber resiliency, quantum safe. They're looking at modernizing. Okay, maybe I want to take these applications and apply another level of security or stability by putting, using the new Z16 or the new systems that were announced. Thinking about their security systems, basically planning for quantum safe today. Also with the new Telum chip, everything is on chip. And also you're hearing a lot of stuff about AI, artificial intelligence with the on-chip accelerator. So I've added those 3, and I'm going to be, in future, when I talk about modernization in some of the future, I'm going to be talking about some of those and how customers are taking advantage of those. And so I kind of went through all of those really quickly, Trevor. So if there's any questions, just let me know, because I went through those really quickly, just kind of an advent of time, because I could go through a lot of this in detail, but I didn't really want to go through a lot of them. So are there any questions?
Well, at the moment, there's nothing in the chat, but if people have got any questions for Dusty, if they can type them into the chat, we'll ask him. So have you been involved with those customers that have actually done it? Are they customers of yours, or are they ones that you've just seen presented at Share?
No, actually, in my prior life, they were customers of mine that actually worked on the implementation. So I was very intimately involved with all the implementation. And I'm actually kind of taking those experiences, because it's easy to say, well, you can do this. But if you haven't ever done it, or you haven't physically worked with someone through the issues of, from start to finish, sometimes seems like a very daunting task. But if you can see, the successes of others, learn from what you did from other applications, these have been done, and these were just 5. There's other customers that are doing a lot of modernization, both inbound and outbound. at all applications.
Okay, great. We've got a question then. Are these solutions exploiting ZOS Connect as a requester, or what technology is used in this solution?
Some of these are using ZOS Connect as a requester. Some of them are using a product that, when I came from a prior life at a company called GT Software Adaptogen, they're using the Fabric to do that. Any API requester, either one of those, it'll be the same environment.
Okay, thank you.
I mean, I think the key there is making it easier possible. If you make it easy for if you make it easy to do, and you kind of take all the heavy lifting off. And also, is one of the customers, once they created this, they kind of came up with the Swiss bank kind of came up with a common requester, where rather than writing a new requester, they basically have one requester and you just tell it what API you want to call. So you can do some abstraction off the top of that also.
Yeah, sounds good.
And I can provide more details and more context on all this. I didn't really want to go down into the bowels of how we did everything. So, you've got my email. If you have other questions, you can contact Trevor or send me a question directly.
Yeah, I was just going to say that if anyone does have any more questions for Dusty, then email me. I'll pass them on, and I'm sure Dusty will get back to you fairly promptly with that.
Also, as a commercial, if you're in the U.S., we're going to have the share conference in August. We're going to have a large contingent talking about mainframe modernization. We'll be talking about IMS and CICS there. So that will be in August in New Orleans, I believe.
Okay, yes, nice advert.
Yeah.
Yeah, well, I can't see any more messages coming up. Anything else in the chat? So I'll move on and say thank you very much, Dusty. That was really interesting. And it's really good to see people are doing stuff, that you can do it. You talk to people who aren't mainframers and they think mainframes are just giant boxes with flashing lights that can't really do very much now and are sort of 40 years out of date, but they can't they? They can do anything you want with them.
That's correct. And one of the things that was why I put my caveat up there is the mainframe is modern. All the systems on the mainframe are some of the most modern on the planet. And it's just, we have to change the way we think about the mainframe and the systems there.
Yes. No, I do find it annoying. I mean, I was looking through the headlines of news stories with mainframe links, and all of them seem to be mainframe modernization, and all of them seem to be about moving to the cloud. Well, you've just proved that there's so much more you can do with your actual mainframe. So that's brilliant. So yeah, thank you very much. We are a virtual user group, so as usual, imagine that you can hear a virtual round of applause. So yeah, thanks very much. Let me go back to sharing my screen then. So there we are. That's Dusty's presentation. News, yeah, sadly I haven't got any news. I haven't seen any press releases for IMS related news. So let's go on to articles and blogs and things. So we've got moving to OSAM encryption, the easy way to get more IMS database security. And that's by Paul Gandolfo. And it's in the IMS part of the IBM Z and Linux One community. And that was published in March. Avoiding downtime, bottlenecks, and other dramas with better IMS Connect workload routing. That was by Adam Limpert, and that's in the same area. And that was just very slightly earlier in March. But going back to February, just after our last meeting, we've got curious how IMS 15.3 performs on the new IMS Z16 platform. And that was by Amanda Stevens and Justin So. And again, it's in the same area. So that was February. Right, coming soon. So this is what you've got to look forward to. 6th of June, then we've got James Martin. We've had him speak before. He works for Rocket Software, and he's going to be talking about simplifying IMS performance problem identification and determination. So put that one in your diary. And then on the 8th of August, we've got IBM's Tracy Dean, who I'm sure many of you have seen speak at other conferences. And she's going to be discussing what does IBM Z Cyber Vault mean for an IMS environment? And things like Cyber Vaults, I know there are Dell equivalents and others, they seem to be the way forward for security and backup. So that'll be quite interesting to see how that affects IMS users. Oh, yes, well, those of you who are working for vendors on this call, we're always looking for new co-sponsors. So if you're interested, drop me an email. And for anyone else who's now thought up a question for Dusty, that is my email address. You probably had loads of emails from me over time, but send it there and I'll pass it on. And of course, just a reminder that you can keep up to date with what's happening in the world of IMS and the virtual IMS user group. We've got a page on Facebook, we're on Twitter, and we've got a LinkedIn group as well. I've got the YouTube logo there to remind you that these meetings are all recorded and they are on YouTube, so you can find out and watch previous ones. I think Dusty was talking about some of his earlier presentations. They are available, so you can access those. And the other thing, I've got the hashtag. If you do use social media yourself and you want to talk about this meeting, then it's hashtag virtual IMS. Okay, well, that's all for this meeting of the virtual IMS user group. So can I thank you all for attending? I particularly want to thank Dusty Rivers for today's presentation. And of course, I want to thank BMC Software, who are currently sponsoring our user group. So thank you all very much. That's it. And I look forward to seeing you on the 6th of June. So thank you and goodbye.
Thank you, Trevor.